I think I managed to finish part 2 of our exam. It was about orchestration, and I'll try to explain how I did that. However, I don't really know. I just tried to do something for 4 hours, and I managed to make it work. So the final result looks like this. We have this interface where you can change something. You have access to database through backend, and you can change values in there. So that's final result I managed to get. Now I'll show how I got there. So on the right there's the actually no it's I'll just open the version the blank version of the exam to show how it was initially. So on the right you can see version which they gave us on the exam, which we had to manipulate. On the left there is my solution for the whole thing. The first thing I started to do and is trying to make these services into deployments and service pairs. So first of all, the hardest one is for the database, because we need to assign volumes, persistent volumes. For that I created a folder here on my host machine, and in the deployment for Postgres I made this two things: persistent volume and persistent volume claim. For each module you can find an example on how to make it, on its syntax, in this file. I'll send it as well. So yeah, persistent volumes, here they are. I just copied this thing to here. This one is for creating volume, this one is for claiming it, and then we have name of this thing, of the claim, and we use it in our deployment, in Postgres deployment, in somewhere, I think, yeah, here. As for the deployment, for deployments we need to use version app/version 1. For everything else, services and claims and volumes, it's just version 1. Here, kind deployment, metadata, we have name of this thing and namespace. Every module of mine is in this namespace, just to be consistent, but it can be anything actually. I have one replica because we only need one database thing, and here we have different things. I'm not sure what some of them do. For example, actually no, this is the label for this application, so it can be accessed by other things. And here the container part, again, name, image. I just copied image from here. Then environment. I'll explain environment later, but we need to create .env file with all our variables. I just took it from here. As you see, environment, these two variables from here. So they are in here in the .env file. But also we'll have to change some of them. For example, host and this link. So then port. Again, port is taken from compose file. It's here. Volume. I think it's its own volume in this pod, in the pod with this container. It just looks like that. I'm not sure actually what it does. I mean, I have ideas, but doesn't matter. That doesn't matter. Also, resources, it's not important, but it's nice to have to not have any problems and errors with this container. Then we are assigning the internal volume of this spot to external to persistent volume, which we made, which we created, and here we have we're referring to persistent volume claim. Actually, I'll just open this thing. So initially we only had compose.yaml, and it just says data. It just shows data we have to transfer to deployment files. Deployment is just deployment.yaml file. I created 3 of them for each service, but it's actually possible to just implement everything in one. You just have to separate these services with this thing. And for each deployment, we have to make service. Here it is, a service for a Postgres deployment. It references its name is starts with the SVC. It's standard form which Nathan asked us for. So I think they will deduct points or something if we will not use it. So it's important. So SVC Postgres. Again, the namespace is my namespace, and here is config for this service. We're just we are referring to this application, to this deployment, and we have port, internal port for this deployment, the same as here, and the target port. Actually, I can say that this things it's easier to remember if we'll just reference to this port. So basically, what it is the first thing is a target port, the port on our host machine, but here it's inside of the cluster. And the second port and ports in compose is the same as port in deployment. So this is all for Postgres part. Then we are moving to our backend. It's Fast API. Here the same thing, only we didn't need any volumes, so we can start with deployment. Then the name is Fast API. Namespace is the same as in other things, but here we have 3 replicas because multiple users can connect to this thing, and it's necessary. I mean, it will work with 1, but why not 3? Here we have our app name, and here we just do the same thing as with Postgres container. The only thing we are taking, firstly I took image from Compose, but then I realized that there's a problem with this image, so I had to rebuild it. But I'll explain it later. Now it's not that important. Anyways, you can just take a link from here, and it will work perfectly. So this is the same thing. Ports, as I explained, here we have Fast API ports, 8000. So here is 8000 as well. If here was, for example, 8000, then here still 8000 because we are taking the right part, the internal port. Oh, actually, no. I think I'm wrong. Then here would be 8080 because it's exposing port to the cluster. Anyways, it's I think you'll figure it out on the exam. Here we're importing our environment again, and resources. You already know what it is. This I already explained services. Here I have external and external and internal ports the same, 8000, and we just changed names of service and app at references. So this is about Fast API, Gradio, basically copy paste from Fast API, but changing names and image link and ports, of course. Here ports are referenced from here. Also, the only difference is that we are accessing frontend. This is frontend. from external machine, so from our laptop directly. So we need to define node port. It's external address, external from cluster. So here for type of this service, I think we need to set node port, and for here we are adding node port at 3000. Wait, 30,000. Why 30,000? Because I'll explain it later. First, I have to explain what K3D is. K3D are our virtual machines, I'd say. Not virtual machines, but they imitate different workers. So here we are defining them. Basically, this thing is in the Notion file. Oh, wait, yeah, in the Notion file. You can find it somewhere here. I'm not sure where it is, but everything in here will be in Notion file as well. I mean, the example of making it. Wait, yeah. But we have to define volume. As we have our persistent volume in Postgres, we want to set its destination on our machine. So on the left part, here's destination, this folder. On the right part, destination in master folder in cluster. These are available ports. That's why 30,000, because one of these ports is 30,000. We want to access one of them. And I'm using 7 agents. Actually, it's overkill. I think 3 will be enough. But anyways, I just wanted to test what it would be with 7. Doesn't matter. After we set it up, all of this, we're just going to here. Actually, now I have my everything running, so I'll just stop it for now. Wait, I need like a minute for that. All of these commands are also in Notion file. So now I want to stop K3D clusters. It was somewhere here. Yep. Just copy the command, paste it. Oh wait. Show me my notes. Oh, I understand what the error is. In Notion, to how it's called, not colon, like minus signs are interpreted as 1. So here we want to have 2 before all, and it's deleting. Again, all comments are here, so now I'll use this one, K3D cluster create. Actually, to show debugging process, I'll try to make it as it was before. So here it is. I'll just change image to the original one, and also I'll change it to how it was with this thing. So yeah, we'll have it like that, just to show. It will give us error back right now, but I want to show how to deal with them. So now it's blank page. We can create everything from 0. First of all, what we need are K3D clusters. As I already shown, here's the command to create them. For K3D config, I showed it as well, I think. So we are making it. Here we have to wait for a bit. After that, we want to create namespace matching our namespace in our config files. So kubectl create we're making this namespace nice, and now we can deploy our deployments. So here's the command. We're just copying it. Actually, have different names. So first we'll deploy Postgres, then radio and fast API. So no errors right now, and we can check if these things are running. We have to go to Kubernetis extension in our VS Code, and we're just reloading this thing because it's not updating automatically. We are going to workloads, deployments, and we see none. Oh, because we have to change our default namespace. By default, it's default. It's marked with this thing, with the star. We need to use namespace on our desired one. Now we can check workloads, deployments. We'll wait for a moment. Here they are: fast API, Gradio, and Postgres. We want to see them. And here they are. They should glow green, like with a green dot. If they are not, that means that either they are not started yet or they crashed. So I'll just check what happened. For example, Postgres, it's the main one, the easiest one we can do right now. We're pressing describe, waiting for a bit, and oh, it didn't start yet because it's still pulling image of Postgres. Let's reload again. Okay, we just need to wait for a bit for it to start. Again, describe. It's still pulling the image. What about Gradio? That's weird. They are still pulling these images. Alright. Oh, about Fast API, it already failed. Oh, I see why they failed, because we didn't implement our environment. So to do that, first of all, we'll have to reload the whole thing so we can delete everything in kubectl, delete all. And as for environment, we have to transfer .env file into format of secret of kubectl, because it uses its own format. And we can do that using this command. Here is the name of our secret, so you can change it, but you'll have to match it with your deployment files. So for example, here it takes secret ref name cluster.environment, and here is the same. So I'll use this command, and we have to do that in our namespace. So this command, and to make it in our to create it in our namespace /n and namespace name. And I will wait for a moment. Here it is, it's created. And now we can try to deploy our deployments again. So fast API. Radio. Wait, where and Postgres. So yeah, now they seems to be starting. We can check it again in here, just reloading the whole thing. Oh, and we can see that one of them tries to start, but probably it fails. No, it started. So let's reload again. It's also possible to check these things through command line. Here it is, here's this command, but I prefer using this visual extension. So yeah, Postgres now is running. We can check it. Normal, and all of these are true. So Postgres is fine, we can leave it alone for now, and check problems with Gradio. It's still pulling the image. Okay, we can leave it as it is for now, and open another deployment. Okay, it pulled it successfully. We'll probably have to wait for a moment. I'm wondering why they pulled them so long. They don't wait that much. Oh, Fast API seemingly is running. Here it is. It's green. Fast API is backend, so we have no way to access it right now because it's internal in the cluster. Let's check what about Gradio. Still pulling. That's weird. When I was working on it, it did it like in seconds. Now it takes a lot more time. You can just get logs of the thing. For that we need to use this command to see our active pods. Here they are, and we'll just take, container creating. Okay, one seems to be running. Let's check it. Here you can see the same thing. So one pod is running, so we probably may try to connect to it. I'm using localhost 30,000 because it was exposed in there. But we still cannot connect. What if I'll reload? They all are running now. Okay. But localhost is still inaccessible. Let's wait for a bit more. Maybe it's still loading. It's running, but I want to see why it's not loading that fast. So we can get logs of this thing using this command. You can find it in notes file as well, Notion file as well. So let's check logs. There's nothing, so probably it's not running. Yes, here it is, finally loaded. Wait, now it crashed probably. Let's check what happened. Are they still online? Okay, it didn't crash, but we have error accessing backends because here you can see error code. I'll just copy it to analyze easier. Here's our error. It's fetching something from Fast API port 8000. Maximum retries exceeded. So basically, it cannot connect to Fast API. Yes, it's saying it right here. What it means? It means that we probably messed up with the name of the thing, because normally it should automatically access pod with corresponding name if it's in the cluster, and we had to include not pod's name but service name. And in Fast API, our service name is SVC Fast API. So basically, what we want to do is to change. I'll show on the on this thing. So here we were. Wait. Boom. Yeah, here it is. Here we were passing backend URL in Gradio, and currently it's incorrect because we want to access service rather than pod itself. So we want to include service name in here, and it is SVC Fast API. So what I'll do, I'll just change backend URL to the right one, the correct one. Now we have to again restart everything. I'm doing it stopping the whole thing and changing secret thing. But I think there are better ways. For example, updating our deployments and updating our secret. But I didn't do that. I'll probably learn how to do that later. So now we are waiting for them to be deleted. And we have to delete our secret as well. Okay, I'll just use this one. And now we can generate secret again. Here it is. And we'll try to deploy everything as well. So radio, Postgres, Fast API. And we have to wait again. So yeah, I'll probably have to find a better way to do that. Oh, it looks like they're running already. Let's try to connect. Not yet, we have to wait for Gradio to update. We'll just wait a bit. I think I'll cut out all of these moments afterwards, but I think it will be a long video still. So finally it loaded. Now we have to check the error message in accessing database if there will be one, but there will be one, I'm sure. Let's reload it. Yeah, error fetch again. Here it is, finally did something. We can see IDs and stuff. So probably it already accessed database, though I thought it will not. Check, I forgot if I changed everything or not. I'm not sure. I think it accesses everything already. Let's try to save something. Boom. Here it is, a lamp is added, and now if we'll reload the page, it should keep it there. If it's not, that means that I'm not sure why, but sometimes it's not working. So yeah, here it is, it keeps it. And let's check if I can change this thing. Yeah, it looks like everything works, but it's weird because Postgres host is still Postgres. It's still named Postgres, though it should have been service Postgres. So maybe I did something wrong, but I hope not. Wait, because before that they didn't run like that. Do we have Postgres host in here? Actually, no. I think it just doesn't care. Didn't take it at all. So it was faulty. I didn't have to implement it in here. And yep. Other mistake we could do is like. Wait a minute. Actually, I didn't expect it to work because initially it didn't work because this this image referenced Postgres without service, just Postgres, and it couldn't find it. But now somehow it managed to get to it. I'm not sure what I did here, but anyways, I think it's like more or less 80% of what you should know to pass the exam. I hope so. I'll be training more. I'll try to explain some things more, but for now, I think it's like the most important thing to make it work as at least somehow. So I think you'll get more than 50% for this thing if you'll manage to make it up. So yep, thanks for watching. Have a nice exams.